let's have a look at Unit 4, Chapter 2, that is Transaction Management. This is the syllabus. Transaction basically in DBMS means, for example, you're transferring money from your bank account, say A, to your friend account, say B. The set of operations would be like read your account balance, deduct the money from your balance, write the remaining balance to your account, and read your friend's account balance, add the amount to his account balance, write the new updated balance to his account. The operations in transactions are there are mainly two operations. Read X. Read operation is used to read the value of X from the database and store it in a buffer in main memory. Write X. Write operation is used to write the value back to the database from the buffer. Asset properties. Assets basically stands for atomicity, which means transaction takes place at once and doesn't happen at all. Consistency. The database must be consistent before and after the transaction. Isolation. I for isolation, multiple transactions occur independently without interference. D. Durability, the changes are successful transaction occurs even if the system failure occurs. So basically, as I explained earlier, in atomicity ensures that all operations or transactions reflect in database or not. Suppose account A has balance $400 and $700. B has $700. Account A is transferring 100 to B, debiting 100 from A, crediting 100 to B. Let's say the first operation passed successfully while second failed. In this case, balance would be 3 while B would be having 700 instead of 800. This is unacceptable in banking system. Either the transaction should fail without executing any of the operation or the process should be complete. So atomicity consists of rollback function and commit function. If there is a failure in the transaction, abort the execution immediately and roll back the changes made to the transaction. Or commit. If the transaction executes successfully, commit the changes to the database. Consistency. Database must be in consistent state before and after the execution of the transaction. For example, if A is transferring $1,000 to B, A's initial balance is 2,000 and B's initial balance is 5,000. Before transaction total sum was 7,000, but after transaction total sum is still 7,000, which is very logical, right? The total sum of money cannot change. So this is what consistency means. The data is consistent before and after the execution of the transaction. Isolation. Uh, a transaction shouldn't interfere with the execution of another transaction. So if the transaction were to run in isolation, then the second transaction would have to read the correct balance $300 before debiting 100 once the first transaction went successful. Durability. Once the transaction completes successfully, the changes it has made into the database should be permanent even if there is a system failure. The recovery management component of database system ensures that the durability of transaction. Asset properties are the backbone of database management system. These properties ensure that even though there are multiple transactions reading and writing the data in the database, the data is always correct and consistent. The state diagram. State diagram consists of certain states such as active state, partially committed state, failed state, and committed state, aborted state, and terminated states, respectively. DBMS schedule. A series of operations from one transaction to another transaction is known as schedule. It is used to preserve the order of the operation in each of the individual transactions. When the multiple transactions are running concurrently, then there needs to be a sequence in which operations are performed because at a time only one operation can be performed on the database. Types of schedules in DBMS. Serial schedule and non-serial schedule. Non-serial is further divided into strict, cascadeless, and recoverable. In serial schedule, a transaction is executed completely before starting the execution of another transaction. For example, suppose a schedule has with two transactions T1 and T2. If all instructions of T1 are executed before T2 or all three instructions of T2 are executed before T1, then S is said to be serial schedule. Non-serial schedule contains many possible orders in which system can execute the individual operations of the transaction. The non-serial schedule is a type of schedule where operations of multiple transactions are interlinked. Unlike the serial schedule, this schedule proceeds without waiting for the execution of the previous transaction to complete. This may give rise to problem of concurrency. Non-serial schedule consists of strict, cascadeless, and recoverable. Strict schedule is the if the right operation of a transaction precedes of conflicting operation of another transaction, then the commit or abort operation of such transaction should also precede the conflicting operation of the other transaction. Cascadeless schedule. In the cascadeless schedule, if the transaction is going to perform read operation on a value, it was it has to wait until the transaction who is performing right on that value commits. Recoverable schedule. In a recoverable schedule, if a transaction is reading a value which has been updated by some other transaction, then this transaction can commit only after the commit of the transaction here, which is updating the value. For example, here TB is performing read operation on X. After the TA has made changes in X using WX, the TB can only commit after the commit operation of TA has been successfully completed. Coming to the next topic, that is serializability in DBMS. When multiple transactions are running concurrently, then there is a possibility that the database may be left in an inconsistent state. The, in an inconsistent state. Serializability is a concept that helps us check which schedules are serializable. A serializable schedule is the one that always leaves the database in a consistent state. There are types of serializability. There are generally two types of serializability: conflict serializability and view serializability. Conflict serializability is one of the types of serializability which can be used to check whether a non-serial schedule is conflict serializable or not. A schedule is said to be conflict serializable if it can transform into a serial schedule after swapping of non-conflicting operations. The operations are called conflicting operations if the following three conditions are satisfied. Both the operations belong to separate transactions, both work at the same data item, at least one of them contains one read operation. Conflict serializability. There are three transactions T1, T2, and T3, so the precedence graph contains three vertices. To draw the edges, these nodes or vertices follow the below steps. So these are the steps given. You can check it out. And after the end of all these steps, the precedence graph will be ready and it does not contain any cycle or loop. So the above schedule S2 is conflict serializable and it is equivalent to serial schedule or above the schedule S2 is transformed into the serial schedule by using the following steps. So these are again some of the given steps. You can check it out. And at last, the precedence graph is equivalent to schedule S2. Next is view serializability. It is a type of serializability that can be used to check whether the given schedule is view serializable or not. View schedule called as a view serializable if it is view equivalent to a serial schedule. Equivalent. Two schedules S1 and S2 are said to be view equivalent if both satisfy the following condition. Initial read. An initial read of the data in both the schedules must be same. For example, let's do schedule S1 and S2. If transaction T1 reads the data item A in schedule S1, then in schedule S2, transaction T1 also reads it. View serializability. Update read. In schedule S1, if the transaction T1 is reading the data item A, which is updated by transaction Tj, then in schedule S2 also Tj should read item which A is updated by Tj. And next is final write. The final write operation on each data item in both the schedule must be same in a schedule S1. If a transaction T1 updates data item A at last, then in schedule S2, final write operation should be done by T1 transaction. Concurrency control protocols. Concurrency control in database management system is a procedure of managing simultaneous operation without conflicting with each other. Concurrent access is quite easy if all users are just reading the data. Problems of concurrency, lost updates, uncommitted dependencies, and non-repeatable read. Why use concurrency method? To resolve read write and write conflict issue. Concurrency control helps to ensure serializability. Concurrency control protocols. There are certain protocols. These are log-based protocols, two-phase locking protocol, timestamp-based protocol, and validation-based protocol. Log-based protocol is a mechanism in which transaction cannot read or write the data until it acquires an appropriate log-based protocol help to eliminate the concurrency problem in DBMS. It consists of two types, binary logs and shared exclusive logs. Shared exclusive log is read-only log, and exclusive log is a data item which can read and as well as write. Xlog is requested using logx instruction. Two-phase locking protocol. Two-phase locking protocol, also known as 2PL protocol, is a method of currency control in DBMS that ensures serializability by applying a log to the transaction data, which blocks the transaction to access the same data simultaneously. Two-phase locking protocol consists of growing phase and shrinking phase. In this phase, transaction may obtain lock but may not release any locks. Shrinking phase, in this phase, transaction may release lock but not obtain any new lock. Timestamp based protocol. So it is a time protocol which uses the time a system time or logical counter as a timestamp to serialize the execution of concurrent transaction. Timestamp based protocol ensures that every conflicting read and write operation are executed in a timestamp order. The older transaction is always given the priority in this method. For example, suppose there are three transactions T1, T2, and T3. T1 has entered the system at time 12:10. T2 has entered the system at 12:20. T3 has entered the system 12:30. Priority will be given to transaction T1, then transaction T2, and lastly, transaction T3. Validation based protocol. Validation based protocol in DBMS, also known as optimistic concurrency control technique, is a method to avoid concurrency in transactions. In this protocol, the local copies of the transaction data are updated rather than the data itself, which results in less interference while execution of the transaction. The validation-based protocol is performed in the following three phases: read phase, validation, and write phase. In read phase, the transaction in read phase, the data values from the database can be read by the transaction, but the write operation or updates are only applied to the local data copies, not the actual database. Validation phase. In this, the data is checked to ensure that there is no violation of serializability while applying the transaction updates to the database. Write phase. The write phase, the updates are applied to the database if the validation is successful, as the updates are not applied and the transaction is rolled back. Recovery techniques. There are certain recovery techniques uh, as database system, like any other computer system, are subject to failure, but the data stored in them must be available and as when required. So there are some recovery techniques such as the log x read item t comma x write t comma x old value new value, in which the log entry records the transaction t, changes the value of the old value database item x from old value to new value, commit, abort, and checkpoint. Recovery techniques are undoing, deferred update, immediate update, caching, buffering, shadow paging, backward recovery. So these are all the recovery techniques. And by this, we come to the end of the chapter. I hope you all have understood it in a nice way. And here this chapter ends. Thank you very much.